Okay, November 2018, paper 2, variant 1. Question 1 is asking you about a micrometer screw gauge which has been removed from the syllabus, so you can just cancel out this question. Question 2, a small light ball is dropped from the tall building. Which graph shows how the speed of the ball changes with time? As the speed increases, what happens to the air resistance? The air resistance increases, and therefore the resultant force acting on the ball decreases, which means that the acceleration decreases, and eventually the acceleration becomes zero, meaning that the ball is moving at a constant speed, or the terminal velocity. So C would be the answer. C would be the correct answer because finally it reached the terminal velocity. Question 3, a runner runs at 300 meters at an average speed of 3 meters per second and then 300 meters at an average speed of 6 meters per second. We need to find the total or the average speed. How can I calculate the average speed? Average speed equals total distance. Total distance over total time. Total distance is 600 meters. How can you find the total time? By dividing the question into two parts. First part, you can find the time by saying time equals distance over speed, in which 300 over 3 is 100 seconds. Second part is time equals distance over speed again, but 300 over 6, which is 50 seconds. The total time would now be 150 seconds. So 600 divided by 150 would be 4 meters per second. Question 4. This is actually a really interesting question. You have a balloon and you have a metal block. The mass of the metal block alone is 100 grams. And then you have the balloon filled with helium. The balloon is filled with helium. Which statement can be deduced from this experiment? Actually, we can cancel out three answers, three very quick wrong answers. First of all, there's no such thing as a negative mass, so B would be incorrect. There is no such thing as a negative mass. C, the helium has a mass of 9 grams. If the helium had a mass of 9 grams, then the total mass would have increased. The total mass would have been 109 grams, not 91 grams. So C is actually wrong. The helium has a density which is less than the air, and therefore this balloon wants to rise up, which is kind of creating an upward force on the balance. There's an upward force exerted by this helium balloon. So A is incorrect. Why? Because he's saying the balloon exerts a downward force. No, it's actually exerting an upward force on the balance. The remaining answer, which is D, is the only correct answer. How is it correct? 91 grams. Can I change 91 grams to newtons? Can I find the weight of this mass? Yes, but first of all, you need to change the mass into kilograms. So 91 divided by 1000 is 0.091 kilograms. And then to find the weight, you just multiply by 9.8 or by 10. For simplicity, it would be 0.91 newtons. And that's why D is the correct answer. Question 5. A liquid has a volume of 0.04 meters cubed and a mass of 30,000 grams. Find the density. Density equals mass over volume. But first of all, you need to divide the mass by 1000 to find it in kilograms. So basically you have 30 kilograms divided by 0.04. If you use your calculator, this would give you a mass of 750. Okay, mass of 750, a density of 750 kilograms per meter cubed. Question 6, a resultant force of 4 newtons acts on an object of mass 0.5 kilograms for 3 seconds. What is the change in velocity caused by this force? How can I find the change in velocity? You can use one of two equations. Either you can use the equation for the acceleration, force equals mass times acceleration, and then you can find the change of velocity, or you can use the other equation, which is the impulse equation. They're both the same equation. They are the same equation. Let me write down the impulse equation. Force times time equals m v minus u. V minus u is the change in velocity. V minus u is the change. So basically, we need to find the V minus u. We have the force and the time, which is force times 4 times 3 equals 0.5 v minus u. Basically, you can divide by zero point 0.5. So 12 divided by zero point 0.5 is 24 meters per second. So the change in velocity is 24 meters per second. You do not need to find the initial or the final velocity. You just need to find the change in the velocity. Okay, which quantities are both vectors? Acceleration and force definitely are both vectors. Okay, a moving ball with a momentum, not a velocity, not a mass. It has a total momentum of 25 kilograms per dot meters per second, collides head on with a wall. A tree bounds with the same speed but in the opposite direction. With the same speed but in the opposite direction. The time of collision is 50 ms, milliseconds, meaning that we need to divide this time by 1000, so it's 0.05 seconds. What's the average force? How can I find the average force? Using the impulse equation. Force times time equals v minus mu. mv minus mu. What's mv and what is mu? mv and mu are both momenta. The initial momentum was 25 kilograms per meter cubed, 25 kilograms dot meters per second. So 25, this was the initial momentum. What about the final momentum? It was also 25, but it was negative 25. Why? Because it has changed the direction. It changed the direction. So initially, mu, the initial was 25 and the final was negative 25. So negative 25 minus 25 equals force times the time, which is 0.05. 0.05. All you do is divide 0.05. So negative 25 minus 25 divided by 0.05. This would give you a total force of 1000 newtons. Of 1000 newtons. Which device is designed to convert chemical into kinetic energy? Chemical into kinetic energy, definitely the car engine. It takes an input of chemical energy, the fuel, and then it converts this fuel into kinetic energy as the car moves. Okay? Okay. Yeah. An object initially at rest is dropped from a height of 12 meters. The change in gravitational potential energy, okay, the change in gravitational potential energy is 565 joules. The frictional forces are negligible. Find the speed when it hits the ground. What is the speed as it hits the ground? Well, I don't have the mass. Yes, you do not have the mass, but you can use the equation. You can equate the gravitational potential energy, which is mgh, to the kinetic energy, which is half mv squared. And then you can just cancel out the masses and you have gh equals half v squared. To find the v, to find the velocity, we can say square root 2gh. Square root, so basically we need to find square root of 2 times 9.8 times the height, which is 12. Times the height, which is 12. So the answer would be around 15.5. It could be a little bit less, okay, since we are using the g as 9.8. A man climbs a ladder. Which two quantities can be used to calculate his useful power? To calculate the useful power of the man. How can we find the useful power? The useful power, we need the energy and the time taken. Energy and time taken. So energy is the work done and the time taken. So it is C. Energy over time. Power equals energy over time. Question 12 has been removed. This is cancelled. Do not solve question 12. Question 13. A wash basin has an exit pipe covered with a plug of an area of 12 centimeters squared. The chain is attached to a center plug. The wash basin contains water at depth of 0.8 meters. The density of water is 1000 kilograms per meter cubed. What is the force acting on the plug? Force, density, pressure. So we can use both equations. Okay, both equations of the pressure. Force times area. Force over area. Pressure equals force over area, which is equal to rho g h. rho density times G times H. To find the force, all you need to do is rho GH times the area. You have the rho, you have the density 1000, you have the G 9.8, the height 0.08, 0.08. And then you have the area, which is 12 centimeters squared. 12 centimeters squared. Definitely, you need to convert this area to meters squared. How can you convert it to meters squared? Basically, by dividing by 100 squared. Dividing by 100 squared, which is 0.0012 times 0.0012. Okay, it would be a very small number, which would be around 0.96 newtons. 96 newtons. Okay, good. Question 14. This is a Brownian motion. The Brownian motion. Why do the smoke particles move randomly? Why do they move randomly? Because they are hit by the air molecules. They are hit by the air molecules. The smoke particles are hit by the air molecules. Okay, moving on to question 15. How does the pressure change with the volume at a constant temperature? Pressure and volume are inversely proportional, which is D. Inversely proportional, which is D. Question 16. Distance between two electricity pylons is 60 meters. An engineer fits a cable of length 62 meters between the pylons. Why does the engineer choose a cable that is longer than the distance? Why does he choose a distance, okay, which is much longer? In winter, what happens? It contracts. Winter, the cable contracts. So we need to allow for the contraction in the cold weather. You need to allow for the contraction in the cold weather. Question 17 has been removed. Question 17, thermometers have been cancelled. Question 18, an object of mass 800 grams, specific heat capacity 250 joules per kilogram degree Celsius is heated. It absorbs 5,300 joules of energy. What is the increase in temperature? Energy equals mc delta t. So basically we need to find delta t, which would be energy over mc. But you need to take into consideration that the mass is 800 grams, and therefore you need to divide it by 1000. Why? Because the heat capacity, the specific heat capacity, is 250 joules per kilogram degree Celsius. If it was per gram degree Celsius, it would have been okay. You wouldn't have converted the mass, but the mass you need to convert it in this equation. Okay, so this is 0.8 kilograms, 5,300 joules divided by 0.8 times 250. Okay, 5,300 divided by 0.8 times 250. This would give you a final answer of around 27 degrees Celsius. On a cold day, a shiny metal rod feels colder to the touch than a black plastic rod. Metal feels colder than a black plastic rod. Why is that? Because metals are good conductors. Okay, good conductors. Metal rod is a better thermal conductor than the plastic rod, which is correct. Okay, 19 is definitely B. Okay, better thermal conductor than the plastic rod. One end of the copper bar is heated at a high temperature. Which mechanism is responsible for the transfer of thermal energy to the other to the other end of the copper bar? Which mechanism is responsible for that? Definitely, it has to do with what? It has to do with the lattice vibrations and the electron or the free moving electrons. Okay, both of them. Why? Because this is a copper, which is a good conductor of electricity. It has lattice vibration, and definitely the free moving electrons help with the transfer of the energy. Now, the wave is moving from shallow to deep, from shallow water to deep water. What happens to the waves? The waves speed up. The speed increases Meaning, when the speed increases, as you go to the deep water, the speed increases. What happens to the wavelength? It also increases. Wavelength increases. This is refraction. Yes, refraction. As you move from a shallow region to a deeper region, the speed increases and the wavelength increases. Which of these diagrams has a longer wavelength? The only one with a longer wavelength is C. If you check the distances between them before reaching the boundary and then after they pass through the boundary, in C it definitely has increased. Which statement about the image formed in a plane mirror is correct? In a plane mirror is correct. Definitely the image is virtual. Yes, the image is virtual. Question 23. What is the refractive index of the glass? How can I find the refractive index? We had three equations. We could have used one of three equations. Can I use the equation for the speed of air, speed of light in air over speed of light in the medium? No, because I do not have the speed of light in the medium. Can I use sine theta A, which is sine the angle of the light in the air, over sine theta M, which is sine the angle of the light in the medium? We could, but we do not have the angle in this diagram. You do not have the angle in this diagram. But you do have the angle in this diagram, which is 90 degrees, which is a very special case. This is a very special case. Why? Because in this case, 44 is the critical angle. Is the critical angle. So you can use the equation which says n equals 1 over sine C. 1 over sine 44. 1 over sine 44. It's as simple as that. Okay, this would be B, 1.44. Okay, 1 over sine 44 because this is the critical angle. And if you use the other equation, which is sine over sine, sine 90 over sine 44 would also be the same. Sine 90 is 1. Sine 90 is 1. 24 different parts of the electromagnetic spectrum are used for different purposes. Which statements are correct? Statement 1, infrared waves are used in television remote controllers. Yes. Statement 2, radio waves are used to transmit television pictures from satellites. No. Microwaves are used in satellite transmission. Ultraviolet waves are used for intruder alarms. No, this is incorrect. Infrared radiation is used in intruder alarms. X-rays are used for security checks. Yes, definitely. So only 1 and 4 are correct. Iron is used for the core of a transformer, and steel is used to make a bar magnet. Which statement explains these uses? Iron is a magnetic material, steel is a non-magnetic material. No, both of them are magnetic materials. Iron is a permanent magnet. No, iron is a temporary magnet. Okay, steel is a permanent magnet. Yes, iron is a non-magnetic. No, so the only correct answer would be C, temporary and permanent. Question 26. 4 microphones are placed at equal distances from S. Which microphone detects the sound from S first? It would be the one traveling in a solid, which is B. Okay, sound travels in solid the fastest in the solid. Okay. Question 27. Demagnetization has been removed. So we can just cancel out this question. Demagnetization and magnetization of permanent magnets have been removed from the syllabus. Question 28. The diagrams represent two different electric fields. Which row? Okay, a single electron is located in each of these fields. We have an electron and an electron. Which row gives the correct direction of the force on the electron? In which direction will this electron move? In which direction will this electron move? We have two fields directed upwards. You have two fields which are directed upwards. Where are the positive and negative poles of these fields? Positive and negative poles of these fields. If the direction is moving upwards, therefore, this is the positive end of the field and this is the negative end of the field. Again, the same for this field. Okay, You have the positive end and you have the negative end. A negative electron would definitely move downwards. A negative electron would definitely move downwards. Why? Because it's repelled by the negative plate and it is attracted by the positive plate. So direction of the force is downwards, and the stronger or the larger field would be field one. Field one is definitely stronger than field two. Why? Because the lines are closer together. The lines are closer together. Question 29. The resistance of a component in a circuit is found using an ammeter and a voltmeter. How are the ammeter and voltmeter connected? Definitely the voltmeter is in parallel while the ammeter is in series with the component. Voltmeter parallel, ammeter series. Which table develops the greatest power? Greatest power. Power equals what? VI. Power equals VI. So you just multiply all of these voltages and currents. 12 times 3 is 36 watts. 100 times 0.4 times 0.4 is 44 watts. 400 kilovolts times 0.1 milliamperes. So kilo and milli, if you just multiply them, it would be 40 watts. 240 times 0.2 would be 48 watts. So the greatest power developed is D. Okay? Okay, good. Yeah, question 31. That circuit diagram shows a fixed resistor and a thermistor, okay, used in a potential divider. What happens, okay, what happens to VR and VT, VR and VT, as the temperature decreases? As the temperature decreases, what happens to the resistance? The resistance increases, and therefore the voltage of this component increases. If you have another component in series with this component, then the voltage of that other component would decrease. Why? Because the total voltage is constant. This is a battery. So the battery has its voltages, its potential difference or EMF divided onto these two components. If you increase the potential difference of one of these components, then the other component definitely, the potential difference of the other component would decrease. Okay, they have to be equal. If you add them both up, if you add both voltages, if you add both potential differences, then the potential difference or the total potential difference has to be equal to the total EMF of the battery. Voltage هنا of VT increases, voltage of VT increases, and voltage of VR decreases, which is A. Okay, which is A. Moving on to question 32. Under which circumstances does the ammeter show a reading other than zero? The ammeter shows a reading other than zero. This is a diode. This is a diode, and this is a DC power supply. DC power supply. DC power supply, you could change, oh, if it's a, yeah, you could flip the battery if you want to, but if you have, for example, P positive and Q negative, the current would pass this way. And would it pass through the diode? Yes. And would the ammeter reader give a reading? Yes, it would. So in the only case in which the ammeter would give a reading would be if P was positive and Q is negative. When P is positive and Q is negative. There is no other case in which the ammeter could give a reading. Okay? Ammeter could not give a reading if Q was positive, for example. Why? Because the diode would not allow the current to pass in this branch. It wouldn't allow the current to pass in this branch. 33 is cancelled. Definitely, it is cancelled. That was easy. Question 34. Either a fuse or a circuit breaker can be used to protect protect electrical cables from large currents. When a fuse is used, where should it be connected? And when a circuit breaker is used, where should it also be connected? Both of them should be in series. Both of them should be in series on the live cable. They should be in series on the live cable, which is at X. They have to be in series and on the live cable. So it is X. Question 35. The current, 3 amperes in the conductor. It's changed to 6 amperes in the opposite direction. 6 amperes in the opposite direction. Which effect does this have on the magnetic field? The magnetic field, definitely it will increase. It will increase. Why? Because you increase the current. But the magnetic field will be reversed. So it's in the opposite direction. C. Question 36. A wire is placed in a strong magnetic field where the current is passed through the wire. It moves upwards as shown. What happens if the current is reversed? And this is an extra easy question. Definitely the movement will be downwards. The motion is now upwards. What will happen? The motion will be downwards if you reverse the current. Question 37. Which diagram represents the structure of a neutral atom? A neutral atom has to have the same amount of the same number of protons as electrons. So the only correct answer would be B. When uranium nucleus absorbs a neutron, it becomes unstable and undergoes fission. Okay, it splits. A uranium, okay, it absorbs neutron, it splits. It produces barium and krypton and 3 neutrons. Barium, let me zoom in. Barium, krypton, and 3 neutrons. Can I balance this equation? Yes, you can balance this equation. Simply balance the mass number on the left-hand side. So on the left-hand side, you have 236, okay? And the atomic number would be 92, which is the same. On the right-hand side, you need the mass number to also be 236. So basically, you have 144 and something in krypton, and 3. This is not 1, this is 3. Why? Because you have 3 neutrons. So you have 3. Basically, a total of 147 plus something, 147 plus something, would give you a total of 236. So if you minus 236 minus 147, 236 minus 147, this would give you 89. The only mass number 89 is krypton 89. And if you say the same goes for the atomic number, the total atomic number should be 92. 56 plus what? Plus 36 would give you 92. Okay, plus 96 should plus 36. So the only answer is A. The correct answer is A. Moving on to 39, you have X, Y, and Z. X was stopped by a sheet of aluminum, Y was stopped by a sheet of plastic, and Z was stopped by a lead wall. Then X is beta. X is beta. Y is alpha. And Z definitely is gamma rays. Z is gamma rays. Question 40, you have a table that shows the results, okay, before the background radiation is taken into account. Before the background radiation is taken into account. In which range does the half-life of the radioactive isotope lie? Okay, you have 20 counts per minute. 20 counts per minute. So if you have background radiation, what do we do? I said minus, divide, plus. Minus, divide, and then plus. 100 minus 20 is 80. 80 divided by 2 is 40. And then you plus 40 plus 20 again, which is 60. 60 lies somewhere in the middle, so it's between 4 and 6. Between 4 and 6 minutes. Okay,